particular example, I'm going to do synthetic division because of this simplicity of the denominator, just a single x plus or minus a number. So let's do synthetic. Okay, -2 here, 3, -2, 1, and then bring the 3 down. 3 times -2 is -6, plus -2 is -8, -8 times -2 is 16, plus 1 is 17. And this is your remainder. The quotient is 3x minus 8. So the oblique asymptote is 3x minus 8. Okay? Let's guess the graph of that thing. We have x-axis, y-axis. This is x-axis, this is y-axis, the origin is right here. We have a vertical asymptote of x equal to -2. Okay? And we have the oblique asymptote of y equal to 3x minus 8. You guys see that this is the line, slope is 3, y-intercept is -8. So the line is going to look like this, right up. This is -8, intercept, okay. This is -2, okay? And then we have two pieces of the graph. Let me see, this is the graph right here when x equal to 0, this is 1/2, oh, I see it. The graph will be like this. The other one is right here. Okay? And again, inside of our mission, two curves, two pieces of the graph is approaching. When x goes to infinity, the graph getting closer to the diagonal line. X go to -2 from right. It's going to get closer to the vertical line. Same thing here. X go to -infinity. The graph is getting closer to the diagonal line. X go to -2 from the left. They get and the piece of the graph so you get closer to the vertical line at x equal -2, but again, it never intersect the two asymptotes. Okay. Right in here, this line is x equal -2. This line is y equal to 3x minus 8. Good. And so we basically cover some basic properties about rational function. Let me cover one last item of this section, and we call it the end of the video clip. You may ask the question, what happened to the graph that have common factor between the numerator and denominator we cancel out? And the answer is the graph of that type of function will have a hole on that point, at that point. Let me explain it in more detail, what I mean by a hole on the graph. So in this example, we have this. F of x is equal to, what was the old example? How about just make a new one? 2x minus 2 over x squared minus 4x plus 3. Okay? We're going to go over the entire thing on this example. Factor the top out, I got 2 times x minus 1. Factor the bottom out, I got x minus 1 times x minus 3. The domain of this one is all real number x. X cannot be equal to 1. X cannot be equal to 3. Okay? And we checked for the common factors of the numerator and denominator. We found 1. So, cancel out. We only have one vertical asymptote. X equal to 3. What about the horizontal asymptote? This is degree 1 out of degree 2. Numerator is small, denominator. Horizontal asymptote is the x-axis, y equal to 0. The x-axis. Okay? And no oblique asymptote. By the way, if you pay attention to what we covered so far, you will never have horizontal asymptote and oblique asymptote at the same time. Because for horizontal, degree of the top is going to be less than or equal to the degree of bottom. For oblique, degree of top is going to be bigger than degree of bottom. Those two things will never happen at the same time. So you either have horizontal or oblique. Okay? Never have both of them the same. Okay, now let's sketch a graph and you see what I mean by the whole. little domains. I want you to think of this function. 2 over x minus 3, okay? Because when I cancel out the x minus 1, what happens? X-axis, y-axis. This is a line x equal to 3 right here, 0 right here, okay? And the graph will look like this, green color. I don't need that long. Okay. And I declare the two curves, two green curves is the graph of the function f of x equal to 2 over x minus 3. It has one vertical asymptote of x equal to 3, okay? And the difference between this one and the one that I gave you at the beginning is what? About a domain. Domain for this one is only what? X not equal to 3. The domain for the original function that we've been working on is what? X different both 1 and 3. So how do we take care of this? 1 is right here. This is 3, 2, 1. Now I'm glad that our graph have a little hole right here. In other words, it's not going smoothly all the way from negative infinity to 3. The domain is what? All number from negative infinity to 1, except for 1, and then from 1 to 3, and 3 to infinity. But you only see one vertical asymptote that way. In other words, whenever you have a common factor between numerator and denominator, you cancel out when you graph, there will be a little hole. On the graph at that point, okay. And this is the origin, not the hole. This is the origin. Okay. So if you have two common factors to cancel out, the graph will have 2 holes. 3 common factors will be 3 holes. That'll be all. Okay. And I guess this would be enough for this section about rational function. Thank you for watching, guys. If you have any questions, please feel free to ask. Have a good day.